we've talked about this in previous pages, but we've talked about that different studies have done observational studies, or statistical researchers have done observational studies, and then in the headline you see on the news or on the internet or whatever, it says, oh, this one thing causes another. Click here for more details, something like that. So they'll say that there's a cause and effect relationship when really there's no evidence for that. We should not make cause and effect statements from observational studies, but in reality, researchers do it all the time. This does not mean that researchers are drawing incorrect conclusions from observational studies. Instead, they've developed techniques that go a long way toward decreasing the impact of confounding variables. So sometimes observational studies, if you make sure that there are no other confounding variables, like with the hormone replacement therapy example on the previous page, you make sure that you kind of take a group of women who all basically have the same socioeconomic situation, and they have access to basically the same healthcare, and nutrition-wise, they kind of have the same diet. That maybe that you can draw some cause and effect conclusions, but all those confounding variables in the previous study made it so you could not. But if researchers, they think of all the confounding variables and try to, like they said, go take steps toward decreasing the impact of them, then you might be able to draw some kind of cause and effect conclusion. These techniques are beyond the scope of this course, but we briefly discussed a few simplified examples to illustrate this idea. So if you take more statistics classes, depending on your major, or if you take classes for your major, like if it's psychology, there might be, parts of those classes that you'll get more detailed into this, how to minimize the effect of confounding variables to make it so I can have a cause and effect relationship in my study. So here it asks, do you constantly text message while in class? Do you jump from one website to another while doing homework? If so, then you are a high-tech multitasker, which I feel like a lot of people nowadays are, right? In a study of high-tech multitasking at Stanford, researchers put 100 students into two groups. First, those who regularly do a lot of media multitasking, and then the second group is those who don't. The two groups performed a series of 3 tasks. The first was to measure the ability to pay attention. Students viewed 2 images of red and blue rectangles flashing on one after the other on a computer screen, and then they try to tell if the red rectangles are in a different position in the second frame. Second, a task to measure control of memory. Students view a sequence of letters flashing on a computer screen, then recall which letters occurred more than once. The third was a task to measure the ability to switch from one job to another. Students view numbers and letters together with the instructions to pay attention to the numbers, then recall if the numbers were even or odd. Then the instructions switch. Students are to pay attention to the letters and recall if the letters were vowels or consonants. So on every task, the multitaskers did worse than the non-multitaskers. Interesting. The researchers concluded that people who are regularly bombarded with several streams of electronic information do not pay attention, control their memory, or switch from one job to another, as well as those who prefer to complete one task at a time. Interesting. So here the quote is, when they're high-tech multitaskers in situations where there are multiple sources of information coming from the external world or emerging out of memory, they're not able to filter out what's not relevant to our current goal, says associate professor at Stanford. That failure to filter means they're slowed down by irrelevant information. So the multitaskers actually do worse because maybe they're paying attention to things that aren't important, whereas the people that aren't really multitaskers, they're focusing on what they're supposed to focus on rather than letting images bombard them. In this case, the studies are observational studies. Researchers did not manipulate the explanatory variable in an attempt to influence attention and memory. Instead, they just used the subject's self-reported habits to form the 2 comparison groups, the technology taskers, multitaskers, and the one task at a time folks. All subjects participated in the same series of tests, but based on these tests, the researchers observed an association between the multitasking and differences in attention and memory, but they state their conclusions using stronger, casual language. Other researchers may debate whether technology multitasking actually causes an attention deficit and memory problems, but researchers will often, like we said before, use a series of observational studies in an attempt to provide stronger evidence for a cause and effect relationship above and beyond the observed association. We'll see another example now where We outline in a little more detail how observational studies taken together can provide fairly compelling evidence for a causal link. So this example talks about smoking as a cause of lung cancer. Let's see, it says, smoking is a leading cause of cancer and death from cancer. So millions of Americans have health problems caused by smoking. Cigarette smoking and exposure to tobacco smoke, cause an estimated average of 438,000 premature deaths each year in the United States. But notice that the National Cancer Institute clearly states a cause and effect relationship between smoking and cancer. But think about the evidence that is required to establish this causal link. As it says, ideally, researchers would conduct the experiments similar to the hormone replacement therapy experiments done by Women's Health Initiative, but those experiments would be not only difficult to do, but very unethical. I think we mentioned that before. We kind of know at this point that there's an association, at least, if not a cause and effect relationship between smoking and cancer. So having one group smoke and another group not smoke would be very unethical to ask people to do something that's bad for them. The researchers cannot manipulate the smoking variable. Doing so would require them to randomly sample people and make them smoke or abstain from smoking. Obviously, this is impossible, and it's unethical to force someone to smoke. So how can we say that one causes the other, that smoking causes cancer? Researchers can approach this challenge in different ways. They often use advanced techniques for making statistical adjustments with an observational study to control the effects of confounding variables that could influence the results. So an example would be the cell phone usage and brain cancer study. So in this experiment, they actually went and found people that had brain cancer already. They identified a group of 469 people with brain cancer. They paired each person who had brain cancer with a person of the same sex, of similar age, and the same race who did not have brain cancer. Then they compared the cell phone use for each pair of people. The matching attempts to control the confounding effects of sex, age, and race on the response variable cancer. With these adjustments, the study will provide stronger evidence for or against a causal link. And that's because those would be confounding variables of sex, whether you're male or female, similar age, so you can't say, oh, this person was old, kind of old, quote unquote, so they are more likely to get cancer, or race, maybe certain races are more likely to get this kind of cancer than another. So they've made those so that they no longer apply because they were comparing someone who had brain cancer, someone who didn't. They were of similar, demographics, I guess. However, even with such adjustments, we should be cautious about using evidence from an observational study to establish cause and effect. So researchers use these types of adjustments in the observational studies with hormone replacement therapy. We saw in that research that results were still misleading when compared with those of an experiment. So kind of the idea here, the overall idea is experiments are always better in that way. You can kind of come up with a cause and effect relationship, but experiments are harder to do, and sometimes, like in this case with cancer, it's unethical because you don't want, if you have a feeling that smoking causes cancer or cell phone usage causes brain cancer, you wouldn't want to force people to do it a lot, one group to do it a lot, just because it's unethical. So, with that in mind, how can the National Cancer Institute state as a fact that smoking causes cancer? Well, they use other non-statistical guidelines to build evidence for a cause and effect relationship. They review a large number of observational studies. So instead of just doing one study, they do a large number, which usually kind of builds your case a little better, I guess, is one way you could say it, with criteria that, if met, provide stronger evidence of a possible cause and effect relationship. Here are some examples of the criteria they used. The first one is, there is reasonable explanation for how one variable might cause the other. So, for example, experiments with rats show that chemicals found in cigarettes cause cancer in rats. So that, depending on your viewpoint, that might be unethical as well because you're making rats smell cigarette smoke or breathe in cigarette smoke. It's therefore reasonable to infer that these same chemicals may cause cancer in humans. Okay. Second is, consider these experiments together with the observational studies shown the association between smoking and cancer in humans. We now have more convincing evidence of a possible cause and effect between smoking and cancer in humans. So a lot of times if something's unethical to do to a group of humans, a sample, they might do it to a rat or some primate maybe or something. Second, the observational studies vary in design so that factors that confound one study are not present in another. So, for example, one observational study shows an association between smoking and lung cancer, but the people in the study all live in a large city. Air pollution in a large city may contribute to lung cancer. So we can't be sure that smoking is the cause of cancer in that study because, yeah, that could be air pollution. It may or may not be, but there's not really any way to rule that out. Another observational study looks only at non-smokers. This study shows no difference in lung cancer rates for non-smokers living in rural areas compared to non-smokers living in cities. So that's a good, smart thing to do, right? They did another observational study that looked at people that don't even smoke. So cigarettes are no factor in this. It's only the air pollution. And they showed that people who live in big cities with lots of air pollution or rural cities where there's not a lot of air pollution, the lung cancer rates didn't really affect it. So that's kind of taking that confounding or would-be confounding variable and kind of throwing it aside. So if you consider these two studies together, the second study suggests that air pollution does not contribute to lung cancer. So now we have more convincing evidence that smoking might be the cause of lung cancer.